solving inequality is one variable. In many ways, solving an inequality in one variable is just like solving an equation in one variable. The math's the same. But what makes it different is now we're doing it inequality. If it's been a while since you've done inequality, let's kind of recap what inequality is. It's these expressions down here, less than and greater than. So less than looks like this. I like to think about it like it looks kind of like an L. You can make it look like an L, like that's a less than sign. And greater than is this one. That's a greater than sign. If you ever have a line underneath it, that is equal to. You can also be the number. Sometimes you're just less than a number, sometimes you're that number bigger or smaller. So that's what makes it inequalities. Other than that, the map is almost the same. There's one thing with divided by negative or multiplied by negative, but everything else is the same. So let's talk about how we graph it also. Because when you solve these, you're not just going to solve the equation, you're also going to graph it so you can visually see what's going on. So let's just do a couple examples. So n is less than 0. So let's just say this is 0. The way we graph it, when it's just a less than sign, no equal to, it's going to be an open circle. That stands for not equal to. So you have to be either less than or greater than 0. You can't be 0. In this case, less than, when it's written in this form, like a proper mathematical form with the variable on the left-hand side, I like to think about it, you can just follow the arrow here. That guy tells you how you should go. We should be going this way. So we're going to go to the left. Less than. And what this line here is, that is your variable. This is n. We're saying n is less than 0. That's literally what it's saying, right? N is less than 0. So the line you're drawing is your variable. You could be any of these numbers less than 0. N is less than or equal to 0. So same concept, here's 0. Our circle is going to be closed now because it's equal to. And same idea, notice how we're going to the left, right? The arrow's going to the left. So, like I'm saying, this guy, if you're in proper math notation, variable on the left, this guy should match this guy. If you're in proper math notation, if like variables on the right hand side, you can always just switch it to the left and then follow it. A number is greater than 0. So, in this case, whoops. So we have 0, and then greater than to be an open circle to the right. So, because again, this guy should be matching this guy. And again, that line is your variable, so n is that way. And then a number greater than or equal to 0, same idea, but now it's greater than or equal to, so you be a closed circle and to the right. So those are the equations we're going to draw. And other than that, like I said, the math is mostly the same. We're just going to use our exact, when we want to solve this inequalities, we're going to use our properties of inequalities, which are just like properties of addition and subtraction. Right? You can add both sides, you can subtract both sides. You can multiply and divide for both sides. The one rule is you must reverse inequality symbol when c is negative. So if you multiply and divide by negative, you must flip the sign, flip the inequality. And we're like, why? Well, let's look at an example. Let's say I say negative 2 is less than 5. And then we multiply both sides by like negative 1. Right? If we don't flip the inequality, look what happens. You get 2 and you get negative 5. If I didn't flip the inequality, that would be wrong, right? 2 is not less than negative 5. So when you multiply divide by negative, to make up for the multiplying by negatives is always wonky, you have to flip the inequality. So that's why we flip the inequality. Because we multiply by negative, it kind of changes the hierarchy. So that's why we do it. So when you multiply divide by a negative, it's only when you multiply divide. It doesn't work for adding subtracting, just multiplying and dividing. You must flip the inequality also. Okay, so with that in mind, let's do an example. So I want to solve this inequality and we're going to graph the solution. Keep in mind our first rule of solving equations is simplify both sides first. So I want to simplify this left hand side first. So we're going to distribute the negative. So negative 12x plus 4 plus 6x greater than or equal to 16. Now notice I distributed a negative, but I didn't multiply both sides by a negative. That's the only time you have to flip inequality. When you distribute, you simplify, you just keep on doing it. Okay, so now we're going to add up, we still have to simplify, we still have to add up like terms. So I'm not done yet on this side. So we're going to add the negative 12x with the 6x, and I get negative 6x plus 4 is greater than or equal to 16. And now we basically have a two-step equation, so we're going to solve this like normal. Let's get rid of this 4. So we're going to minus 4 from both sides. Whatever you do on one side, you got to do it to the other side. These cancel out. You get negative 6x is greater than or equal to 12. And then now we have to divide by negative 6. Right? So to get rid of that 6, we're going to divide by negative 6. And here we go. Right? 12 divided by negative 6 is a negative 2. That's not the issue. The issue is we're dividing by a negative. Anytime you divide by a negative, you got to flip this inequality. So that's going to be less than. Right? So the rule we just talked about, anytime you multiply divide by a negative to both sides, you have to flip the inequality. So now we have this. Let's plot it. So here I'll put negative 2. It's in the middle there. It is notice how it has a line underneath it? It's equal to, so it's a closed circle. Equal to. That's why we're doing that. And again, which way do we go? Follow the arrow here, right? If we have in proper notation, so we just follow that arrow there. It's going this way. And this is our arrow, this is our x. You don't have to actually write x here, but just so you know, like that's what we're talking about. X, all these numbers here are less than negative 2. That's what's going on here. If you want to add more numbers, you could. 0's on this side, negative 3's on this side, negative 1's on this side, but that's the general idea. So that's how you solve an inequality. That's how you solve an inequality and graph it. Let's try another one just real quick. So same thing here. Let's just shoot that negative 3. So I get negative 6x minus 6 is less than 2. Right there, right? Okay, now we have a two-step equation. Whatever we do one side, I gotta do the other side. So we're gonna add 6 to both sides. I'm running out of space, so I'm gonna do it over there. So I get negative 6x less than 16. And then we're gonna divide by negative 6. So we're dividing by negative 6 one more time. So again, we got to flip the inequality. So x is greater than 16 over 6. That's not a nice number. Let's see. I can reduce it a bit. If you want to reduce, you're supposed to divide both top and bottom, and we're in the denominator by the same number. So let's divide them both by 2. Now I get 8 over 3. A little bit better, so it's like 2.6. I'll put 8 over 3 here. And it's a negative 8 over 3. Right, okay, now which way are we going? It is an open circle. No such no line underneath it. It's an open circle. And look at the arrow, right? Pointing that direction. We're going to the right. Right. Again, we have our x on the left-hand side, so we can just follow it. So go in that direction. And that's our graph. Now let's keep on going, solve some more. So this next one, this has an inequality on both sides. So again, we're going to treat it the same way. Solve it like you know how to solve an equation with an inequality on both sides. So first thing I want to do is I want to get rid of one of the inequalities. We only want to have one inequality. So I'm going to get rid of the smaller one and we get rid of the 2x. So we're minus both sides, 2x from both sides. Whatever you want, I get the other side. You get negative 5 is less than 3x minus 22. So we want to get rid of that negative 22. So let's add 22 to both sides. We're going to get 17 is less than 3x. Then let's divide by 3. And we're going to get 17 over 3 is less than x. Again, that's another ugly fraction. It's like 5. It's 5.22 over 3, so 5.66. We can just leave it at 17 over 3. The bigger issue, though, if you graph it like this and you follow the same rules, you went, okay, 17 over 3. You went open circle, you went that way, you would be wrong. Notice the x is not on the proper side. X should be on the left-hand side. So you can either go, okay, it's pointing in the wrong direction, and go this way. I want all the numbers bigger than 17.3, right? 7.3 is less than x. Or to me, the easiest way to do is just flip it. Get the x on the proper side, so flip it. X is greater than 17 over 3. Oh, so we should be going this way. So keep that in mind. If you want to use the shortcut of you just follow like this, pretend it's like an arrow, you just follow that. It works, but it has to be in proper math notation to do that. Okay, let's talk about infinitely many solutions and no solution. So in this one here, let's do this first one. So let's shoot the negative 3. So negative 6x plus 15 is greater than negative 6x plus 9. We have an x on both sides, so that's what we always do, right? Let's get rid of it by it. Let's add 6x to both sides, get rid of that x. In this case, they both cancel out. We get 15 is greater than 9. And just like before, if it's a true statement, then it's infinitely many solutions. If it's a false statement, it's no solution. And right here, we have a true statement. So this is infinitely many solutions. 15 is greater than 9. So that'll be our answer. If you want to do it on a number line, all it is the whole number line. It goes both directions. It could be any number on a number line. That's a very bad drawing of a number line. That's the whole thing. Both directions. It's another bad drawing of a number line, I'm sorry. Okay, so that's infinitely many solutions. Just like before. If you get a true statement, infinitely many. If you get a false statement, no solution. So like this next one, if you did this one, you should do that 2, 4x minus 6 less than equal to 4x minus 5. Notice how we have 4x on both sides. So just like before, we're going to cancel this out. Minus 4x minus 4x. It will cancel. You get negative 5 is less than equal to negative 6. Now, negative 5 is actually not less than negative 6, right? When you owe money, this is that you owe less money, so it's actually a bigger number. So this is a false statement. So this is no solution. And then how do you graph no solution? Don't. There's nothing to graph, so that's its answer. So that's infinitely many, that's no solution. It works just like before. If it's a true statement, infinitely many solutions, whole number line. False statement, no solution. Okay, last thing we're going to do, we're going to skip that one for time. Let's solve an application problem. Derek wants to order some roses online. Florist A charges $4 per rose plus $40 delivery fee. Florist B charges $15.15 per rose and $25 delivery fee. What number of roses is less expensive from Florist A from Florist B? So we're just going to make an equation for each one. So let's say Florist A. $4.75 per rose. So rose is going to be our variable, because we don't know how many roses we're going to buy. So let's say rose is X. If it's per rose, that's how much we're going to multiply by. So it's going to be 4.75x, because we're paying that much per rose, plus this $40 in delivery fee. That's a lot. And then for Florist B, same concept. It's $15.15 per rose. So X plus the delivery fee is $25. Should be inequality. We want to find out when Florist A is less than Florist B. So we're going to make this inequality here. None of that, we're just going to solve, just like before. So first thing you want to do is get only one x, but now we have two variables, so let's get rid of one of them. Let's get rid of the smaller one generally, so minus 4.75x minus 4.75x. These cancel. I get 40 is less than equal to 25 plus 5 plus 10, so 40 cents, 0.4x plus 25. Okay, so I still want to get the x by itself, so it's minus 25 from both sides. Like that. These are going to cancel out. And I'm going to get 15 is less than equal to 0.40x. Now I get divided by 0.40 to get rid of that. So again, we can put this in your calculator. Divide by 0.4, 0.40. And then we get x is less than, we're going to get 37.5 is less than equal to x. That's what I should say. 37.5 is less than equal to x. And now, again, just like before, notice how x is on the wrong side. I should put it the other way. X is less than 37.5. It's greater than. So for flipping, you gotta flip it. 37.5. Now you can't buy 37.5 roses, so we have to round up. So 38 roses. So what's it saying here? Right? X is how many roses we buy from. How many roses we buy? If we buy more than 38 roses, then it's cheaper to buy from A. If we buy less than 38 roses, then it's cheaper to buy from B, because we set it up like that way. So that's what's going on here. If Derek buys 38 or more roses, then Florist A is cheaper. If he buys less, Florist B is cheaper. Remember, that's the way we set it up. We set up A is less than B. So when we solved that, we got, A is less than B when X is greater than 38. So if you buy more than 38 roses, then Florist A is cheaper. So that's how you do inequalities. And that's this lesson.